Have you ever laid beneath the vast, dark canvas of the night, feeling the world slow to a whisper? Above you, a tapestry of light, woven with a million tiny, shimmering diamonds. It's a sight that has captivated humanity since the dawn of time, a silent spectacle that speaks directly to the soul. In that profound quiet, you might have noticed it's the way they dance, a gentle flicker, a subtle pulse. These distant suns don't just sit there, they seem alive, winking at us across the immense, dark ocean of space. It's a celestial ballet, and it begs the question, why? Why do stars twinkle? It feels like a secret message, doesn't it? A language of light whispered from across the cosmos. We see it as a gentle, rhythmic dance, a sign of their distant, magical nature. But the truth behind this beautiful illusion isn't happening out there, millions of light years away. It's happening right here, just above our heads, in the very air we breathe. The journey of a star's light is one of incredible endurance. Imagine a single photon, a tiny particle of light, born in the fiery heart of a star countless years ago. It travels across the vacuum of space, a straight and unwavering path through nothingness. For millennia, its journey is uninterrupted, a pure, steady beam cutting through the void. But in the very last fraction of a second of its epic voyage, it encounters a new, final obstacle: Earth's atmosphere. Our atmosphere isn't a calm, uniform blanket of air. It's a turbulent, ever-churning ocean of gases. It's filled with countless tiny pockets of air, all at different temperatures and densities. Think of it like looking at a coin at the bottom of a swimming pool. The water's surface ripples and distorts your view, making the coin appear to shimmer and move. The air above us does the exact same thing to starlight. As that steady beam of starlight enters our atmosphere, it's bent and bounced around by these pockets of air. This bending of light is called atmospheric refraction, because the air is constantly moving, swirling in invisible currents we call wind. The light is refracted in different directions from moment to moment, deflected one way, then another, its path scrambled in that final chaotic stretch. What arrives at our eyes is not a steady stream of light, but a flickering, fragmented signal. Our brain interprets this rapid change in brightness and position as a twinkle. So, in a way, the twinkling isn't from the star itself, but from our own sky, singing its turbulent song. If you were an astronaut floating in space, looking at the same stars, you would see no twinkling at all. You'd see them as they truly are, steady, unwavering points of brilliant light. The twinkle is a phenomenon unique to us, a reminder of the beautiful, invisible ocean of air that protects us and gives us life. Perhaps you've also noticed that some bright stars in the night sky do seem to twinkle at all. They shine with a calm, constant glow. These are often not stars, but planets in our own solar system. Why the difference? It all comes down to a matter of perspective and size. Stars are so incredibly far away that, even through powerful telescopes, they appear as single, infinitesimally small points of light. This pinprick of light is easily disturbed by our atmosphere. A tiny pocket of air can momentarily block or divert that entire beam, causing it to flicker or even disappear for a split second. Planets, on the other hand, are much, much closer to us. While they might look like points of light to our naked eye, they are close enough to appear as tiny, solid disks through a telescope. You can think of a planet's light as being made up of many, many points of light, all bundled together. As this disk of light travels through our atmosphere, different parts of it are refracted in different ways. Some points of light may flicker, but others will remain steady. Our eyes average all of this out, and the overall effect is a constant, stable glow. The planet's light is simply too broad and robust to be completely distorted by the atmospheric turbulence. So, when you see a steady light, you might be looking at Venus, Mars, or Jupiter, our cosmic neighbors. But when you see a flickering gem, you're gazing at a distant sun, its ancient light dancing through our atmosphere. There's a beautiful metaphor in this, isn't there? Something so constant, so powerful and unwavering as a star can appear to flicker and dance when seen through a turbulent medium. Its true nature doesn't change, only our perception of it. It's a profound reflection on perspective. It reminds us that what we see is not always the complete picture. Our own lives can be like that atmosphere full of turbulence, challenges, and shifting currents that can distort our view of things that are, in reality, constant and true. The universe is full of these quiet lessons, written in the language of light and gravity. The twinkling of a star is more than just a trick of the light, it's a story of a journey across incomprehensible distances. It's a story of the invisible, life-giving air that surrounds us. And it's a reminder that beauty often lies in the interaction between the distant and the near, the steady and the chaotic. So the next time you find yourself under a clear night sky, look up, find a star that's twinkling, and remember its incredible journey. Remember the dance it performs with our atmosphere, a fleeting performance just for you, in that very moment. Let it fill you with a sense of wonder, a connection to the grand, silent, and shimmering cosmos. Thanks for joining me on this journey through the night sky. If you enjoyed this cosmic story, don't forget to like, subscribe, and hit that notification bell for more explorations into the wonders of our universe. Keep looking up.